Good morning, everyone. I hope that you enjoyed yesterday evening and today you're ready to listen. Just to remind that you can become an owner of T-shirt for questions after the speech, and we are ready to start. You're welcome.
Thank you. All of you can hear me? What a bad thing. Otherwise, we could have all slept peacefully. After all, it's a Saturday morning, right? Well, to earn money, you have to do something. Namaste. Now, that's a greeting from my country. Coming from here. I'm happy to see you all here on a Saturday morning, and you have no idea what you're getting yourself into. Do you? No? Yeah, excellent. I too. So let's see. Where we go from here. How many of you have done some testing on applications that are hosted on cloud? Okay. And what is the purpose for others who are here? Are you migrating to cloud? Are you using applications on the cloud? What? Sorry? Planning. All right. So testing and cloud. Here is cloud. Here is testing. Testing and cloud. We are done. Do you really think testing could be any different if you have an application on the cloud versus you have an application on the desktop or a normal web server? Do you think there's really going to be any difference between the two? No? Testing is testing, right? There's an application, there's an interface, and you exercise the interface as a black box tester, correct? Actually, you don't even know if the application is hosted on the cloud, right? If it's a third-party application, you have no idea. Just looking at its face, looking at its interface, you cannot tell whether it is an application hosted on the cloud or hosted on a bare metal server inside the company's premises or just on a little server somewhere, correct? So then the question, maybe testing in cloud doesn't really mean testing applications hosted on the cloud, but using cloud to test the applications maybe? But then, what's the big deal? I install an application on a desktop machine, like a tool, like Selenium, or I install it on a machine hosted on the cloud. How does it matter? Again, that doesn't matter? Or does it? So probably it doesn't matter. That means testing as we know, the typical black box testing or even automation or performance testing that we do, it does not get impacted in any visible way. Mind the word visible, any visible way when you are testing applications on the cloud or you are using applications which are hosted on the cloud and you use them for testing. But then, is there something really different? And that is what I really want to talk about. I want to talk about from first principles, not with a formula, in cloud do these things, but from first principles. So for example, how many of you are DevOps or are doing DevOps or your company is planning to get into DevOps mode of operation, all right? The same question that I'm asking you about cloud is going to be asked. How is testing in DevOps any different? Same question is going to be asked for an application which utilizes artificial intelligence inside it. How is testing that any different? And what you need to do is, if you go by first principles, you should be in a position to analyze the situation, to figure out for yourself, how is my testing going to be impacted by use of whatever technology, whatever black box there is, whether it is cloud, or AI, or DevOps, or Agile, or anything else. So we'll talk about that. Okay? So far, so good? How many of you use cloud every day? All of you, right? So cloud is not exactly anything new anymore. But the interesting thing is that not all applications have been migrated to the cloud. And a lot of organizations in the world are now looking at migrating applications to the cloud. Some are already there, others are trying. So let's take a look at what is there. So we are going to talk a little bit about cloud. I'm not going to talk too much about cloud, only those parts of the technology that are relevant to us. Okay? So that's the first thing that we are going to do. And when I say terminology, I don't really mean the entire terminology of cloud technology, but just things that are relevant to us. What are the challenges there? What are the differences between testing on the cloud and conventional testing? And then we'll see how to basically do that testing. What are the new tests, additional tests that we need to do if our application is hosted on the cloud? We good so far? Okay. Please understand one thing. There are many things that could be understood when I use the two words together, cloud testing. Can you tell me what all things those could potentially be? Cloud testing. Testing the cloud itself. I'm a cloud provider like Amazon, like Microsoft, and I want to test my cloud. Does it work okay? I don't think many of us would actually be in the business of testing the cloud itself. So we're not going to talk about that. Okay? What are other things that come to your mind when you hear the two words together? Cloud testing. Device farm. Okay? To host application on the cloud and test it. Okay? What else? Security test. What I mean to say is not the individual tests, but at a high level, what does cloud testing really mean? So, if you say there's a device farm, you've hosted the applications on those, you've hosted the application on cloud, you test it, perfectly fine. Second thing that I said, that's the third thing, test tools or test applications using tools that are hosted on the cloud. We don't care where my application is hosted. But the tools that I use to test, they are hosted on the cloud. Again, that's not of too much of interest to us, except it's a tool that you want to use, and that's about it. And then, finally, you could actually be testing for specific cloud characteristics. And what are those? We'll see that pretty soon. Are you clear about what is actually cloud and cloud computing? It's like a black box. You need some resource. Cloud is like, Santa Claus. Whatever you ask for, you get it. You have no idea where from Santa Claus is actually getting them. Or better still, when you're young, cloud is like your mom or dad. You want something, you tell them without caring how much money does it really cost. And your parents then try to get it for you. If cloud is like my dad, what is it that I'm going to ask the cloud for? I'm going to put my application there, right? So what can I really ask for? When I install an application, what are the things that I typically need? I need hardware. I need software, correct? What kind of hardware do I need? CPU, RAM. What else? Sorry? GPU. Okay. So you need resources on which you can run your code, correct? How much RAM do you need? How much CPU do you need? So there is something called as minimum system requirements. And you ask the cloud, give me a CPU with this much RAM, this much frequency, this kind of CPU, maybe 8 CPU machine with each CPU having 4 cores. Okay? So cloud says, okay, here it is. And later on you realize that you are the next big challenger to Facebook. So just this much hardware is not good enough. You need more. What do? Go to the cloud and say, I need more. And the cloud should be able to provide that. And then, of course, there's software. Software runs on the software. What kind of operating system do I need? What kind of patches do I need? Who provides me those? So again, we go to our dad. Give me more money. So we ask the cloud for all the type of operating system, patches, and so on and so forth that we need. So what is cloud? Nothing but a black box which has ability to give us all our environment that we need. But typically, do you install software only on one machine? Microsoft Office, maybe, but a banking software definitely does not get installed on one machine, correct? So you need a lot of different types of servers. You need to connect them. How do you connect them? So you need some sort of networking connections. Somebody said security. You need to make this secure. So you need firewalls, right? What else do you need? Antiviruses. You need to set up a DMZ. You need to do a lot of different things. What else do you need to do? How many of you set up your own test environments? Okay. And what kind of environments are these, if I may ask, starting from here? But that's on the client side. I mean to say the server side. Okay. Anybody who does server-side installations of your application, where you have database servers, you have authentication servers, you have web servers, you have application servers, you have queuing servers, you connect it to legacy systems, very involved, right? Okay. So, any idea how much money does it take to set up a production quality system for a banking application, for example, or an e-commerce application? Sorry? You don't care? Yeah, you should. Because the characteristic of your servers determine the performance of your application. And if you don't care, maybe it's somebody else's job. If it costs, and it actually costs millions of dollars to produce production environment for critical systems. Millions of dollars. How many of you use 4 types of environments, meaning development environment, testing environment, staging environment, and production environment? All of you? How many of you get your hands dirty on staging and production environments? Okay. How much money do these environments cost? And if you want an upgrade in the environment, how much money does it cost? This is one reason. One, the complexity of setups. Second, the money that it costs, which results in software testers usually not getting involved in the environment setup. Now I'll go a little away from cloud right now and ask you just one question. How soon do you think, in how many years, do you think DevOps is going to be a reality in your company? 1 year, 2 years, 3 years? How many? Never? You already have DevOps. All right. One thing that happens in DevOps is that these walls, the distinction between tester, developer, with Agile that already went down, and with DevOps, the people who do the installations and operate the systems, they're all going away. That means the roles are getting mixed up. And in the next few years, chances are that as a tester, you might need to pick up new set of skills. One of those skills could be environment-related skills. So let's get into it and see whatever I told you about environments and their costs. Are these problems that can be solved? As a tester, is it easy or difficult for you to get into environment setup? Let's take a look at all of these. But you understand what is cloud computing? Shared pool of configurable computing resources. Servers, storage, applications, services, which can be provisioned rapidly, which can be installed and made available rapidly. So these are key characteristics of the cloud. And they have an impact on how we test our application. So while cloud gives you an impression of infinite resources, actually there are limited set of resources, and they're shared amongst people. How many of you have shared stuff in your personal life? For example, you are in a village, cut off from everywhere, and you have suddenly guests who have come, and you do not have enough blankets in the house. What would you do? Maybe ask your neighbors for additional blankets. And imagine now if everybody shared things. So one person has 20 blankets, other person has 20 plates or 50 plates, yet another person has, other things and so on. Whenever I need additional blankets, rather than buying them myself, I go to this person who loans it to me. I have additional, let's say, big utensils to cook food, and I loan them out to other people. Suddenly, with limited number of resources, everybody has more resources. That is the philosophy of cloud, that you have resources and they are shared amongst people, but all the resources are not used by all the people at the same time. And hence, it gives you an impression as if you have large or almost infinite amount of resources available. Okay? So there are 5 essential characteristics of any cloud service that is provided to you. One is on-demand self-service. Now, what does that mean? On-demand, when I need it. Self-service, I should be able to get it. Have you ever waited for a server resource to come into your company or a hardware? You put a requisition, and then it took weeks for the hardware to come in, and then the IT department had to set it up, and after that, you got to use it. Does that happen? How much time does it take? Sorry? A lot. A week, 2 weeks, 4 weeks, sometimes even more, depending on what you are trying to get. A PC is usually easy to get, right? And a server class machine may be harder to get. Sometimes you have to import them from different places, and then you have to install the OS and configure them and so on. So it takes a lot of time. This one says, on demand, whenever I need it, I should be able to get it, and it should be automatic. There should be no human being involved in getting me the resource. As long as I have a working credit card, this is okay. That means I go to the web, I go to the cloud provider, I don't need to make any phone calls, I don't need to put up any long contracts. All I say is, give me a machine with these characteristics, with this operating system, and I should be able to get it. Without any intervention from a human being. So that's a very essential characteristic of cloud. Does it have any impact on testing? It does. Sorry? Positive, indeed. If this is the case, then I am in more control. I need to do probably less planning. I can do things instantaneously. Broad network access, cloud being cloud. Well, actually, I'm reminded of this very interesting conversation a journalist had with one of the bureaucrats. You all understand bureaucrats, right? I don't know how many of you have suffered at the hands of bureaucrats, but if you have, then you would know what I really mean. And this bureaucrat who sets policies for a government is talking to the journalist. And he's saying, for third world countries, this whole cloud thing is a trick. It is a wrong thing being done on us by bigger developed countries. So the journalist asks him, why do you say so? You see, they are putting all the data on the cloud, and in our country, the clouds are there only for 3 months. That means you can use this service only for 3 months. And imagine you put all the data in the cloud, and that cloud has moved away. How will you get your data? And if you are in a forest and you can't see the cloud, how will you get your data? So this is all a conspiracy by the developed countries to keep the poor countries down. Very funny, but this is how some people understand cloud. Broad network access. So if you are putting things in cloud, they should be accessible from wherever you are. Imagine, how many of you have been to China? No? So there's something called as a Great Wall of China, right? Similarly, there's a software equivalent of that, Great Firewall of China. So you can't access a lot of different sites from there, right? So if you're on cloud, you need to ensure that there is connectivity from everywhere, otherwise you land yourself in big trouble. Resource pooling, we have talked about it. Rapid elasticity and measured service are two more things, and I'll go over them one by one. Any idea what is meant by rapid elasticity? Okay. Sorry? You can scale it. What does the word scale mean? Sorry? Add more resources. So if you have a server which has, let's say, 8 CPUs, each having a quad-core CPU, so 32 cores are there, and you have 128 GB of RAM. But this is Christmas time, and a lot more people are visiting your site to buy things. You run a very clever campaign, and now your resources, your servers are overwhelmed. What do? It costs you, let's say, $2 million to put that in place, and maybe 6 weeks. Now you need how much more time? Maybe same time, same money, $2 more million, and 6 weeks of setup. But 6 weeks later, Christmas would be gone. Now what to do? So you should have an ability by which you can add resources on the fly, right? And what happens to those $2 million once you buy that hardware? After Christmas is over, what do you do with that? What do you do with that? It lies there, isn't it? So you need an ability to add as well as reduce, scale up and scale down. It's a very important property of cloud, rapid elasticity. And then measured service. So you have a Gmail account. How much GB of data can you have there on a free Gmail account? 15 GB. What happens after that? They charge you. You have very important mails, you can't let go of them, so you decide to pay Google something, right? How do you know that that 15 GB actually is being consumed and Google is not inflating that figure? You may be consumed only 10 GB, but because Google wants money from you, it says you're consuming 15 GB. Is that a possibility? Yeah? You trust Google. All right. You know, what can I say? Measured service. You are getting something and you are paying for it. How much to pay? There could be one-time fee. There could be a fee independent of how much I'm using, a monthly fee, or it could be dependent on how much resources, how many resources I'm using, and I pay only for the resources that I've used. And that is one of the big pluses of cloud computing, that you pay only for what you use. In fact, there is one more step where cloud computing is going now, called as serverless, but I'll talk about that last. So if I do not talk about it, please remind me that I should talk about that as well. Okay? So what are the 5 essential characteristics? These 5. Do you foresee any of these characteristics having any effect, any impact on your testing? What? No impact? Some impact? Sorry? Performance, okay? So there could be an impact on performance, okay? What else? Big impact, okay? What exactly? But I'm happy with the big impact part. So this presentation is all about what exactly. Please read this slide. I've already explained. I have a bad throat. I would rather your eyes do the work rather than my throat. Any questions from here? Does that give you an idea of what is it that we are asking? Computing capabilities, storage, software, etc., without any intervention, as and when required by the consumer. Broad network access. All services provided by cloud should be accessible using standard protocols. Nothing unique or nothing esoteric should be required. Resource pooling. We have already discussed what resource pooling is all about, but let's look at what are the resources. Processors, storage, we have talked about it. Virtual machine, and we'll talk more about virtual machines a little later. Network bandwidth. Now that's an interesting one. What is meant by network bandwidth and sharing of network bandwidth? Typically, when you hit a server, do you have any idea what kind of speeds do you connect to the internet at your home? 100 Mbps, 50 Mbps, 500 Mbps, doesn't matter what you're connecting at. But if there are 1 million users, look at the bandwidth that would be required on the server side. On the server side, what should be the size of my pipe so that I can cater to all of you? So let's say every user consumes 1 Mbps kind of transfer or speeds. And if there are 1 million users connecting at the same instant, how much bandwidth we are talking about? Somebody has to pay for that bandwidth, right? So cloud actually allows you to have variable bandwidth as well. It can tell you, it can ask you how much, and if you want a thicker pipe, you pay more. If you want a thinner pipe, smaller pipe, you pay less. Now, where are these resources located? We say this is cloud is black box, but ultimately everything should be running on the servers, right? Everything should be running on a hardware. Where is this hardware located? Any idea? So there are data centers, and they are all tied together, and they could be spread across the world depending on your cloud provider. The large ones, they have centers all over the world. You don't know, usually, on which machine exactly your data is lying, where computing is happening, and so on. So as I said, it's all black box for you, but at the back, you have hundreds of thousands of servers working, and you have no idea where your stuff is working. So that's the interesting part about cloud, that there are multiple physical location. Now, does that have an impact on your risks and your testing? Think about it. You don't know where it is. In case of your server, you know where it is, correct? So that's an interesting thing. Read this last line, please. Some restrictions can be placed by the consumer on physical locations such as country boundaries, etc. Now, Russia, for example, doesn't allow LinkedIn to work inside their premises. At least last I went there, it was not allowed. China doesn't allow you access to Gmail and Google and so on. European Union has laws which say all your data should reside inside Europe. If cloud is independent of my location, then it becomes a problem because I'd be breaking law if I host applications and I don't know where my data is going. So you have to take care of this as well. So the cloud providers typically tell you that we will not cross these boundaries. For example, Europe, for example, China, for example, Southeast Asia, and so on and so forth. Elasticity we have discussed, and we are going to take a look at, how does that impact testing very soon. ability to reduce or increase the available resources quickly, rapidly, quickly. So that's the whole idea. Measured service. Now, you all understand private, public, community, and hybrid cloud? Essentially, private cloud is cloud for my organization only. The data centers are in my premises, or I am in control of those. Nobody from outside can access those. So most large organizations which run their internal operations on cloud typically use a private cloud. Google is an example of public cloud where anybody can host themselves, and there security can become a big issue. Multi-tenancy can become a big issue. So why are we talking about these? Because these have an impact on what kind of tests we need to perform. On a private cloud, security may not be that big a concern. But on a private cloud, the amount of resources that you have available may be less than a public cloud. Which means when I'm testing my elasticity, how much really up can I go in terms of increasing my resources becomes an important point. So if you are testing a private cloud, yes, you will test for security, but you'll probably test for elasticity much more than for a public cloud, and so on. Community cloud and hybrid cloud are, kind of mixtures of those, so not really important to talk about. And then there is software as a service, platform as a service, infrastructure as a service. You understand all of that? When we talk of cloud testing here in this presentation, we are going to look mostly here, not here. So just to make you understand what it is, software as a service, like Gmail. You just get the software, and that's about it. You don't need to you don't get to touch the hardware, touch the software, where it is hosted, nothing. It's the software, whatever version is available, whatever features are available, you get those, end of the story. Platform as a service, for the development work, runtime environment is made available, but you have no control over network, servers, operating systems, storage, and so on. So that's about it. That means you get things to develop and run, but you don't control any of the software characteristics of how fast your machine should be, how much RAM it should be, and so on. Whereas infrastructure as a service, they provide you the servers. You don't know what those servers are, but they say, here is the server, so you can ask for RAM, CPU, network bandwidth, configuration, and so on. And this is what we are talking about. And Amazon, of course, is world's biggest cloud provider, but you have Microsoft Azure and a lot of other cloud providers as well. And this is where we are going to focus our testing effort on. How many of you understand virtualization? You worked with VMware or VirtualBox or Virtual PC? Anybody who's not worked with it? Anybody who wants me to explain virtualization? Virtualization is a very big technology without which cloud would not have happened. Now, if you have used virtual machines for your testing, what difference do you think it makes to your testing? If you test only on virtual machines, can you call your testing complete? No? So what kind of test you would not perform on virtual machine, and what kind of test you would perform on virtual machines? What kind of test you would not perform? Sorry? Performance testing, yeah? What else? Anything that deals directly with the hardware. Hardware compatibility testing cannot be performed, right? And so on and so forth. Some of the security testing also cannot be performed because that depends on the environment. And so, virtualization, how many of you heard about containers and containerization? How many of you use them? Docker, for example? Excellent. So Docker makes for a good mix of containerization on top of virtualization. And load balancing, you've heard the word load balancing? Yeah, when you have multiple servers working and you want to distribute the load so that one of the servers is not overloaded, that's load balancing. I'm not going to go into the details of virtualization or hypervisors, but hypervisors are tools that make available or make possible cloud servers. Microsoft provides VMware provides hypervisor, and these are things, you don't use the normal virtual machine. What you use are hypervisors to create a cloud. Okay? What are hypervisors? We don't care. But essentially what you are getting when you ask for a machine is actually a virtual machine. On cloud, you are getting a virtual machine, not an actual machine, not a what is called as bare metal server. Consequently, performance testing in case of cloud needs to be performed for virtual machines. Okay? Because that is what you are getting even for production. Containers, these are lightweight virtual machines where you can run only 1 or 2 virtual machines on a piece of hardware, maybe 4. Containers can be run probably 10 times in number. They take very little memory. It is because of their architecture. We don't need to get into that. And today on cloud, first you have virtual machines. On top of that, you also have containers. And that has its own challenges. So we're not going to talk of how to test when your applications are deployed on containers, but we are going to talk about how to test on the cloud. So we've looked at all of these. Please go through this, because now, of course, there's a break now in a short while. After that, when we come back, we are going to look at how all of these characteristics require you to test for each one of them, and how are you going to test for all the things that we talked about. So you use load balancer for guaranteed service continuity, to handle high traffic, and if there are request spikes, suddenly large number of requests come, you want to handle that. You don't want your servers to crash, so that's where you use load balancers. And when you test your applications which are hosted on the cloud, you need to test them for the characteristics, those 5 essential characteristics. You need to test your applications for performance, for security, and load balancing, and so on. Those are the kind of things that you need to do. How much time do we have now? Over? Yeah, so I'll finish this slide, and then we will take the break, okay? I'm just putting one slide for testing using the cloud, not testing the application hosted on the cloud, but using the cloud. So you have, for example, performance testing. Typically, when you do performance testing, your load generation machine, you need a large number of machines if you need a large number of users or virtual users to hit the server, correct? On one machine, maybe you can run 200 or 300 virtual users, maybe 500. So to do 50,000, how many machines do you need? 100 machines, right? Where are you going to get those 100 machines from? Cloud provides a solution. You ask for those 100 machines, you remember that? On demand, you ask for those 100 machines, you get those 100 machines immediately. You use them for load generation, running your load generation tool, your work is done, you return the machines back. You incur only this much cost. Whereas if you were to go and buy 100 machines, you can imagine the kind of expense and kind of management nightmare you would have. And that is the power of using cloud for testing. There are a lot of security testing tools hosted on the cloud, a lot of compatibility testing tools hosted on the cloud, a lot of cloud providers. For example, LoadRunner. LoadRunner provides you licenses on the cloud. You don't need to install anything on your local machine. You just say, give me an instance, and the LoadRunner comes pre-installed for X number of users, X number of transactions. You just let it loose on your application, and end of the story. Similarly, security testing, there are images available. You say, give me one, and you get a server in like less than 2 minutes, and you can run that tool. Once you are done, you can say, take back your tool, pay for this amount of time for which you use the tool, end of the story. So when we come back, now we are going to take a look at how we are going to do, what kind of testings we are going to do on cloud, and what are the types of tests that can be done only on cloud because of the technology that is being used. So those are new interesting types of tests that you may not have done before, but because of cloud, those are the tests you should incorporate in your day-to-day testing. We come back in 15 minutes.
Yes, now we've got a break for 15 minutes at 11:25. Meet here again.
So essentially, where we left, one of the most important thing for using cloud reason is elimination of upfront investment on tools and infrastructure. You don't need to spend tens of thousands of dollars. You can start work if you have even $100 or less. In fact, Amazon provides you a free account for 1 year as long as you remain within limits of usage and so on. So what we are saying is that what is in business terms called as CapEx, capital expenditure, you don't need to spend that money, and you can use that money for paying salaries to people like us. So that's the advantage of cloud. Some of the challenges are issues related to data integrity, bandwidth, provider network and location, security, legal and compliance, and so on. Now, when you talk of all these challenges, these are things you have to test for. Each challenge is a testing challenge. For example, you know your application is deployed on the cloud, and it would be used by people in a particular geography. You need to look at, are there going to be any bandwidth issues? You need to look at data integrity, because your data is being replicated, being shared across a lot of different machines, and so on. So there should not be any corruption of the data, and so on. So all of these challenges, which we are going to look into in greater detail, are actually the kind of tests that you need to do because your application is hosted on the cloud. Of course, you need data integrity tests, but they become more important when you are hosted on the cloud. Performance, we have already talked about it. That performance is one of the most important type of tests to be done, and why is what we need to understand. Especially for public cloud, for example, Gmail, how many millions of users are there at any point of time? Have you used any application which is hosted on the cloud? Other than Gmail? Which one? Sorry, Jira. Okay. Anybody uses that? Look at so many companies which have their account on the cloud, and one company used, or they did testing on Jira rather than logging the bugs, and tried to do some SQL injection and so on and so forth. It can have an impact on performance of your application. So essentially, this is a multi-tenancy problem which we will see shortly. Unsupported configurations. So your cloud doesn't provide that kind of a configuration, and you can't really use then your application on the cloud, or your customer is going to deploy it on a bare metal machine, actual server, but you want to test it on the cloud because it's easy to set up, but the same configuration is not supported by the cloud. So that's one thing that you need to look out for. When you're doing your test plan, you need to ask yourself, what is the environment configuration, and will cloud really support it? So that's something that you need to look at. Lack of control. You have no control on the underlying environment. So if there are crashes, network breakdown, servers going down, you don't know whether the problem is in the application or problem is in the environment. Whereas on a server that's in your control, you know exactly what is happening. So this is one of the challenges. You need to plan your test environments properly, how to set it up, how much it will be used, how do I disassemble it. Okay? So when you plan testing on cloud, and if it is not private cloud, you are using a public cloud, you are paying by the hour. You are paying by the amount of CPU that you use. That means your environment budgets should be available upfront to you. So if you are a test manager, you need to ask yourself, how much is this really going to cost me, and how are we going to pay that cost? And then you have to understand that if there are additional features that your applications have, for example, encryption, so that consumes additional CPU, additional memory, and so on. And you should not have what is called as cost blindness. You run your tests, next morning you come and you find you have run a bill of $50,000. That's entirely possible in cloud. Because you set it up in such a way that whenever it needs resources, it gets more resources from the cloud. There's no human intervention. Nobody really getting an approval, and it consumes more and more. There's an infinite loop a problem, a bug, and it keeps consuming resources. By the time you come next morning, you've run yourself out of budget. So you have to be careful there. Then there are test data management challenges. First, I have terabytes of data that I need for testing. On a server, it was easy. I had that data available on my local network. I could replicate it, copy it. If it is on the cloud, and I have to upload terabytes of data, you had not planned for that additional time and effort. You do not have enough upload bandwidth, and the uploading of data takes a lot of time. When you're planning for this, when you're planning for your testing, you should plan for this kind of an activity. So issues in loading large volume of data. Then there are restrictions. If you use production data, it's my own company, it's my own production data, and I can use it by proper masking. But even there, I may have challenges, and if it is customer data, I have additional challenges by putting it on the cloud. The customers are happy when you host it on their server, host all this data on your server. But they may not be happy when it's in the cloud, because it's like, any hacker, you are inviting them, come and take my customer's data. I had a very interesting problem once related to data. We had developed an application, and initially it was on physical servers, and we had hosted the database on one local machine, and everything was working okay. But when the client put it on production on the cloud, they configured it in such a way that one part of the data and the database was on one machine, other one was somewhere else, and there was a very slow network between them. What a query took, like probably fraction of a second or maybe 1 or 2 seconds, when they ran that on the production environment set up on the cloud, each query was taking like more than 10 minutes. Initially, they thought our development team had goofed up, and they threatened us not to give any more work. It's after 10, 15 days of investigation that we figured out that this was a problem. And so these kind of problems, because you have different physical servers, different locations connected to each other, you can have a lot of challenges. While this is not a testing challenge, but you should be aware about that, which is, today I am hosted on one cloud. I want to move my installation to another cloud vendor. Can I do that? Because if I use a vendor-specific service to do something, similar service or same APIs may not be available, or same mechanisms may not be available. There may not be a possibility for me to move my data as it is from one cloud provider to another, and I may actually be required to export it on a local machine, import it on a different machine, and so on. So this can be a very big challenge. Interoperability between different vendors, it can become a big challenge. Let's see. So when you test on the cloud, these are the things you need to be careful about. First, setting up the test environment. When you set up test environment on a local machine, and people who know what they are doing, they can fine-tune the parameters. When you do it on the cloud, and the cloud gives you only so many things in the UI, and you do use defaults, are they good enough? That's what you have to do. Challenge, you have to test for access rights, you have to do functional tests, you have to do tests related to backend servers, you have to do non-functional tests, reliability, performance, interop, security, scalability, and stress, and so on. Then there are challenges related to testing migration to cloud, or tests specific to migration on cloud, and automation. So let's take a look at it. First, the process. Test planning, standard test planning. Only thing you do in test planning is look at the cloud, look at all those challenges that we talked about, ask yourself, what are the risks here which are relevant to me? From the environment point of view, from the setup point of view, from the performance point of view, from the response time point of view, from the data integrity point of view, and so on. You use the same test design techniques that you use for testing any application. There are no new test design techniques that you need to look at for cloud testing. So far it's pretty much standard. But after that comes the interesting part where you need to, for your cloud, for example, you know how AWS works, Amazon Web Service works, but you are doing your installation on Sauce Labs Cloud. You need to understand what are the differences between the two and what is available and what is not available. So set up your cloud environment and key cloud functions provided by your service provider. Look at what are the monitoring tools available. So for example, logs. Where are you going to get the logs from? How many of you use logs to understand how good your testing is going? So you need to understand logging in the cloud. Where are you going to get the logs from? So on. On virtual machine, if you look at their performance parameters, how much CPU is being used, how much memory is being used, do you think it really gives you insightful information? No, because it's virtual machine. So you need different tools which can give you data which is equivalent to running your, for example, perfmon. Anybody has used perfmon? You know what's perfmon? Perfmon is a tool that comes bundled with Windows, and you launch perfmon and it gives you a lot of different parameters and so on. For a virtual machine, these parameters may not make sense because there's no actual hardware. But in cloud, though you get a virtual machine, these are parameters which are equivalent to an actual hardware. So you need to make sure that you understand that particular part. Then when you do your test execution, there are additional resources that come into picture. There are communication channels and storage and so on. You need to look at those and see how do they really impact. And when you close your testing, then all used resources need to be released, all storage needs to be released, and you may need to save your virtual machine images for later use. And now I'll tell you some interesting thing that happened with me. When I do cloud trainings, 2-day or 3-day, there's a certification there, Cloud United, which is on how to test on cloud. It's a hands-on course. And so you all get a Amazon or Azure environment, a user ID and a password to go there, set up things, do testing on the applications yourself and so on. And every single time I tell all the people, please, whatever resources you have created, whatever virtual machines you have launched in the cloud environment, whatever load balancers you have set up and so on, after you are done, please shut them down and delete them. Otherwise, it's going to cost me money. I don't know because it's my money or, they are just forgetful. Invariably, 10-15% of the people, they forget, and they have actually set up not one but multiple machines, and they are running full tilt. By the time I go home and try to check up what all machines have been closed, it typically runs a few €100 bill per machine. And that's a loss I have to live with, but that's my money, right? When you work with company's money, your test manager or vice president or so on is going to be very upset with you if you don't do this activity. You have to be very careful to do this. Unfortunately, most of the cloud providers don't provide you a single, very user-friendly interface which tells you what all resources are being consumed and stop all of them. So you have to individually go and stop them. One interesting thing is, I talked about the cloud data centers being in different locations. So many of the cloud providers allow you to choose which location you want to install. And when you choose the location, it gives you resources that are being used for that location. You just see one UI, you think you've stopped everything, but unfortunately the server you created was in a different location, you forgot that. That is still running in the background. Only after the end of the month, when a hefty bill comes to you, you realize there's something still running there. So you be very careful with this. So if you are testing applications hosted on the cloud, you do functional testing and test automation on that. However, if you're using platform as a service, your application is a platform, and you are providing platform as a service and you are testing that, then non-functional testing and automation, they are the important part. And when you are testing infrastructure as a service, there are additional tests that are important. For example, failover and availability testing, multi-tenancy testing, interop, data privacy, scalability, and so on. So let's go through all of them. But essentially, if you are testing this, all of this needs to be tested. If you are testing this, then this needs to be tested. If you're testing this, then this is good enough. Why is non-functional testing not important here? Because this is not in your control. The platform and infrastructure is not in your control. It gives the performance that it gives. Gmail, for example, it gives the performance that it gives. So, so non-functional testing, let's look at them. Availability testing. If it is on cloud, it has to be available 24/7. How do you test it? 24/7 is good, but how do you test it? You run it for 3 years. If it doesn't go down, then you say, now I can release the software. But if it goes down after 2 years, 364 days, then you say, okay, let's fix this bug, let's run it for another 3 years, then we'll release it. How do you do this kind of testing? 5 years? Okay. Any idea? Testing at peak hours? Okay. Okay. Test every 10 minutes? Okay. So what is available? Why would something go down? That's a question. Right. So let's say we are testing the application and we want to test the application. Now, right now we are saying, what if cloud is not available 24/7? That has an impact on your application. The customer doesn't care whether it was the cloud that went down or it was your application that went down. The customer sees only your application. And if your cloud infrastructure is not available, that's a problem. How do you test for your application availability 24/7? So there are two parts. How do you make it available and how do you test for it? When we talk of disaster recovery, we'll see the 24/7 kind of working. But essentially, whenever you want to see that your application is working for long hours, there are two types of tests that you do. One is a test with average load or above average load running for continuously for certain number of days and so on, and look at the parameters. And if you find the parameters are stable, that means if you continue to run it for more time, it's going to be okay. Second thing is, what is going to bring down the application? So it could be, for example, the volume of the data, the size of the data, the growth in the size of the database, and so on and so forth. So you ask a question, if I run it 24/7, after 5 years, what's going to happen? Oh, after 5 years, my database would be this big. I would have, instead of 5,000 users, 50 million users, and so on. So, if I want to test it in 1 week, I grow my number of users from 5,000 to 50 million in 1 week. I take the size of the database that it would be after 5 years, put that there, and then start doing my testing, normal testing. So this is like simulating 5 years in 1 week, compressed time testing. So those are some of the things that you do for availability testing. Then multi-tenancy. What is multi-tenancy? On the same server, you have data from different customers. And that's an interesting thing. How is that data separated? What makes it possible that one person's data or one company's data does not become accessible to other person or other company? So security testing, access control becomes very important. Multi-tenancy means if my application causes some malfunction, it should not cause an impact on other applications hosted there, right? So that's the kind of test that you need to do. What will be the impact of crashes of my application on other application? And if there's other application which is consuming too much resources, how does it impact my application? Mind you, this is not in your control, how the cloud platform is behaving. But how your application behaves when your cloud platform misbehaves, that is the kind of test we are talking about. Do you understand that part? If my cloud platform misbehaves, or other applications on that platform misbehave, what is the impact of that on my application? That is what you want to test in multi-tenancy testing. Okay, this is a very interesting, and I have found many a times a lot of bugs here. Impact of customization of one app on others. So for example, you had a client for your app in India, another client in Europe, another client in US. What is the kind of customization that may happen? For example, locale settings, the 1000 separator, comma versus dot, the currency symbol, the date and time format, and you customize them in one application, and unfortunately that's a global variable, it impacts everybody. How many of you have used Google Sheets in a collaborative mode? So an example is very clear there. Well, if you do some editing in some of the fields, 2 persons are doing it, you still see and you are able to see everything. There are some features where if you sort the data in a particular way and so on, it doesn't impact the view of other person. But the moment you put a filter, it filters data for everybody. Ideally, the filter should be only for the person who is doing it, right? In a collaboration environment, you don't know who is putting what filters and so on. And that's an example of a bug that exists in such application. So an example of impact of customization on others. Security testing, authorization, access control, data integrity, privacy, penetration testing. These are different types of security tests you need to do. And one reason why initially people don't want their applications on the cloud is because they're afraid that they are not secure. So you need to do more security testing even for internal applications for the cloud. Do you get that point? Because it is, if it is public cloud, if it is private cloud, then it's not really that big a problem. Then DR testing. Has anybody ever done disaster recovery testing? A lot of people, you know what is disaster recovery, right? If things go wrong, how can we pull the pieces together and still soldier on, still go on? So we'll talk more of disaster recovery soon. We have already discussed scalability testing. What was that thing that we said about cloud? Rapid elasticity. That means if I put sudden load on it and I have set my cloud in such a way, there's a possibility that when the load increases after a particular threshold, get me more resources. So if my CPU is getting at 80%, pull in more CPU power. Of course, it means I will have to pay more. That's okay. I'm willing to pay more. So what happens is, when you create an instance in cloud, you say this instance should be, let's say, of size small, medium, large. Doesn't matter what it means. So I go for a small size, and then I say when my CPU utilization goes above something, or memory utilization goes above 80% of what I have, switch to a medium one. Now when I switch to medium one, what happens? More cost, correct? And it should be available immediately. It should not so happen that from 80 to 90%, and it's in the back, it's taking too much time. So rapid and elasticity. And when the load goes down, should I pay for more? So I should scale back to small. So that is what we mean by scalability testing. Ability to scale up or scale down. That is one way, increase the resources. Other way is to have multiple servers working in parallel. That means dynamically, I should be able to have more servers added to my mix, which means I need some sort of load balancer, and I have to test. As a tester, I have to test these scenarios. Even if you are not a performance tester, performance of cloud applications as a functional tester also is important for you. And how does the functionality work when suddenly you switch from small to medium? What happens to the transactions which are happening? Small now, medium in a moment. Whatever transactions were happening at that time, do you lose those transactions or do they continue? If you lose them, does it cause corruption of data? Or just by doing the transaction again from the user, everything goes through? You see, now if I switch from one machine to another machine, metaphorically speaking, all my databases, etc., I have to make it from the small machine to the large machine, right? And that's where this whole testing comes from. So are we good with scalability testing? You have to plan for scalability testing in cloud. What is load testing? Load testing is nothing but a type of performance testing, right? Where you put some sort of load meaning 20%, 50%, 75% of rated capacity, and you check the response time and resource utilization. At lesser loads, the size of instance may need to go down to save cost. And there are tools available on the cloud which help you do this kind of testing: SQA Cloud Test, Load Runner, Cloud Test Go, and many, many more. Almost every performance testing tool is now available on cloud. Now, there are many ways to conduct this performance testing, which includes load testing. App on the cloud, load generator on machine in the lab. Look at it. My load gets generated because I already have a lab for doing performance testing. My application on the cloud, my load on bare metal servers or on actual machines. Or it could be that both are on the cloud, or it could be the reverse way. App on the machine in the lab, load generator on the cloud, and so on. We have already looked at elasticity testing. Now, when you do elasticity testing, one more thing that you need to keep in mind is go to your cloud provider, look at all the parameters that you need to set up for setting up elasticity. Each parameter will have an impact on how the system is going to behave. Understand the cloud technology. Because if you uncheck a checkbox, or you check a checkbox, or you choose some value there, it will have an impact on your application's performance. So, in addition to the application performance, you also need to do cloud's performance. How much response time does it have for scaling up and scaling down? If it takes too much time, then that provider is not good for you, or something is wrong in the settings for scaling up, scaling down. So that's where you as a cloud tester need to understand the cloud part and look at the response time. What does it mean? We talked about testing for 24/7. If I inject bugs, errors, not bugs, but if I inject errors in my test data or test environment, the way transactions happen, how robust is my application to handle it? If my application is robust, it will keep running. But there are times when you need to upgrade your application live. So you need to test for those. If the platform crashes, then I need to make sure that I bring down my application, bring it up, or make it a live upgrade. In case of platform crash, the platform comes back up, let's say in 1 minute. How do I test how much time my application would take to come up? And availability and continuity in multi-tenancy. So let's take a look at those in a few slides from now. Anybody who's doing migration of, so these are the type of tests when you are migrating. When you're migrating to cloud, migrating to another location in the cloud, what are you doing? You need to look at that. Migrating to a new service, new platform, or migrate out of the cloud. All these are different types of migrations that can happen with respect to data. And then you need to look at the conversion. When you migrate from one cloud to another service, to a different platform, to a different location, is there any data conversion involved? What are those data conversion rules? How do they work on the input data? Is there any data loss? What happens to the ongoing transactions? If you're 24/7 available and you are migrating, what happens to your ongoing transaction? And what are the tests related to data transfer, speed and volume? Those are the kind of tests you need to do for migration. Otherwise, it's migration testing from an application point of view is like, you test the same tests again and ask yourself, are all functional and non-functional characteristics of my application exactly same as before migration? But these are tests specific to cloud. Disaster recovery. The funny thing, what is disaster recovery? When something goes wrong and things crash, and this particular site is no longer operable because somebody dropped a nuke on it, or it was just a flood, or electricity was not available for whatever reason, I can't stop my operations. So I need to make sure that my application is working from somewhere else. Or my application crashed and it's not coming back up because my hardware crashed, or my application corrupted the software on the hardware, the OS and so on. So what I want is my application to work from some other location, and that's what disaster recovery is all about. These scenarios include hardware, software failure, network outage, power outage, human error, and so on. What you need to do is have your disaster recovery well set, and this is something that never gets tested, almost never. Because to test disaster recovery, you have to actually fail your live system, bring up the backup system, make sure the data is current, and operate with it. That means somebody has to actually pull all the plugs, go to the remote location. Now in disaster recovery, I would not like to have, for example, my disaster recovery or backup server lying in the same building in which I have my live server. Because if there's an earthquake, it will impact both. So what I want is my disaster recovery to include locations which are not likely to be impacted. Same country, so if you have political problems, they'll impact the whole country. Tsunami might impact multiple countries together. So you try to make things as different as possible for your backup service. So that's what you try to do in disaster recovery. The problem is, I need two different setups available all the time. The data has to be synchronized and so on and so forth. I have to upload the data. I have to make the system prepared. So if one server is in Mexico and one server is in China, am I going to fly somebody? Am I going to make a phone call in the middle of the night? How will I really test it is the big challenge. Also, money is a big challenge. You need duplicate infrastructure to ensure availability of capacity. Fortunately, cloud comes to the rescue. Here is an example, something that happened with me. There's a company called Avio. I don't know if they are still alive. I used to use them, and for a lot of my office work and so on. I got this email from them once. Catastrophic hardware failure on hosting provider, the cloud hosting provider. Unfortunately, due to this failure, all Avio data, including backups, were lost. This means all your accounts and data within Avio are unrecoverable. So all my work of 1.5 years, gone. They don't even offer me 1 year of free service for next year. They just say sorry, and that's it. They hope that you will continue to use Avio moving forward. Right? So you need disaster recovery. Two parameters, RTO. How much time does it take after the disruption to restore? And how much data can you afford to lose, which is RPO. So you say 1 hour RPO, that means at any point of time, you'd be able to retrieve the data which is up to 1 hour old, not between 1 hour to 0. You understand what I'm saying? So you need to define this, because the more data you want to recover, let's say you want it 1 second, more cost you have to put in. Why? Because then you need to set up your infrastructure in such a way that data replication, etc., are happening more frequently and so on. So let's not talk of traditional approach to DR. I'll talk about what are the mechanisms. But once disaster recovery has happened, and even if people test disaster recovery, what they don't test is this failing back. What is failing back? Well, you are working on the backup server. Now your main server is back up and running. You need to come back to it. That means there's one more disruption that's going to happen. Right? One disruption which you did not plan for, it happened. Another disruption that you need to plan for so that you can come back to your main server. And that is basically failing back. So it means reversing the flow of data replication so that any data update that were received by the secondary site or the backup site, they make it to the primary site. So there are various failback approaches. Backup and restore, freeze data changes to the disaster recovery site, take a backup, restore the backup to the primary site, repoint the users to the primary site, unfreeze the changes. Now look at what kind of effort this requires, what kind of planning this requires for testing, and so on. Another approach is you have a system which is always available. It has a reverse mirroring or replication. So, there's data that is being replicated all the time. And you freeze data changes to your disaster recovery site, repoint the users to the primary site, unfreeze the changes with relatively quick. Pilot light, warm standby, costs you more money. You have always a system which is up and running all the time. Data replication is happening, but full load is not being shared here. So, in this case, you can have pre-configured AMIs, and virtual machines, they come up like this. Similarly, there are pre-configured machines on cloud providers. They come up in a few seconds. You make a small instance available. It's always up. The database instance is big enough, keeps replicating. The moment disaster happens, you switch from a small instance to a very big instance, and instantly you have everything. So you have some tools, for example, in Amazon called as ELB, Elastic Load Balancing, pre-allocated addresses, pre-configured IP addresses, pre-configured machines. So these are things that you need to do as a tester, make these available, have them configured, and then you test disaster recovery by shutting down the primary site. Automatically, the backup site should come in picture. All the data should be there. Those are the test scenarios you need to do. You're doing a transaction, what happens to that transaction? If there are 100,000 users logged in at that point of time, when you switch from primary to secondary, what exactly happens, and so on. So, you can take a look at the recovery steps later. And this is, how do you fail back? Now, data replication becomes the key here. So there are some of the points here that for data replication, these are things that you need to look at. Please understand, a company like Amazon doing millions of transactions in an hour, the amount of bandwidth that you need between two different servers is huge to ensure that data is getting replicated all the time. There are some slides related to replication approaches, synchronous and asynchronous. Do take a look at it later. When you are testing disaster recovery, you should test frequently, exercise a failover to disaster recovery, test the documentation also in this case, and do different scenarios based on type of loss and so on. This is a test that you could not do with bare metal servers, but with cloud, you can do them very easily. So cloud enables you to replicate the production environment at a fraction of a cost, because you can have a very large environment available which costs you, let's say, $1,000 an hour. But you use it for 10 hours, $10,000. If you went for creating that environment, it would have cost you maybe $1 million. So it's really doable. The type of test that you do for disaster recovery testing: checklist testing, walkthrough testing, simulation testing, parallel testing, and full interruption testing. Full interruption is not done on production. All these tests are done on non-production. So I'm not saying it's a bad idea. It's something that needs to be done so that when it actually happens, you know exactly your disaster recovery plan would work. Thank you so much. These were things. Are there more type of tests? Are there more details? Sure, there are. But I hope that if you look at these challenges, you'd be able to ask more questions. If you have more questions, once after this, feel free to address them to me. I'd be happy to answer them.
Vipul, it's more to share also my experience on this,
Yep,
because
please.
I had a very specific situation with auto-scaling.
Okay.
And usually we do that to take care of the performance,
Right.
when we have more users coming to the site, but also to reduce costs.
Right.
So scale down
Yes.
when the infrastructure is not being used. The problem was, in my case, was an algorithm that was too aggressive on that.
All
So
right.
the system was stopping to answer. And of course, everyone was reporting the issues because it was not the main production site. And whenever the testers or anyone else was looking to the environment, it was working.
Right.
And said, no problem, it's working, so just close it. And next day, it was happening again. And then we realized that the algorithm was so aggressive that it was actually shutting down the instance.
All right.
And as soon as we received the first request, then it wake up again.
Right.
And it seems that it was working. So that was, it was a measure to take down the costs,
Right.
but a little bit too,
Yes.
too more.
Very interesting scenario. Thank you. Any other question that you might have?
Thank you for your topic. Very useful and interesting for me. I have such question. What if your product to client your own cloud? Your own cloud platform where your client will be able to create their own application. How we can test our cloud in such case? Just create all types of applications and test it?
So what are the characteristics of the cloud that are important? You need to exercise those. Those could be exercised with a real-world application, or you could create a dummy application. So for example, something that puts a lot of load or consumes a lot of memory, and then you have your auto scaling, for example, in your cloud, your own cloud, and then you see, is it kicking in? So another thing, for example, if it kicks in at 80% CPU utilization and you can set it to 10%, does it kick in at 10%? Does it kick in at 50%? And so on. So you need to look at those characteristics of the cloud and either create your own applications to test it, or this could be a simulator or a tool which will allow you to do these kind of tests. Creating full-blown applications to test it would probably be an overkill. But there are a lot of open source applications available, some buggy and some not so buggy. You should make full use of installing those and then running tests on those applications rather than creating your own. If you have to create your own tool, which is very specific to your problem.
Okay, thank you.
Pleasure.
Do you have any recommendation for cloud service providers for test? Like we were trying Device Farm and also Google Test Lab and other things. So if you have some already.
No, I have no recommendation of which cloud provider you should go to, Amazon or Google or Microsoft or so on. Whichever fulfills your needs and you have skills. Some of these large providers, they're pretty good, right? So, you have to look at the cost parameter and you have to look at the skills in your development team and environment team. Are they able to basically do those things? Not all cloud environments are equally popular. So if you don't have people with the required skills, that's where you will actually start, get into trouble. Yep.
Hello, thank you again for the topic. And the question is, if we have our application on our own server, and is it a good idea to put the test environment to the cloud?
Why would you want to do it is some scenarios in which you would want your test environment on cloud would be because you do not have money to replicate the hardware for staging server, for example, whereas it would be easier to do it on the cloud. Second reason could be that you want to test those special scenarios like disaster recovery and so on, which would not be very easy to do if you use bare metal machines. But if that is how you are going to do your production environment, then I showed you 6 different types of tests for disaster recovery. You can do 5 on the cloud, but the last one, where you actually test disaster recovery, that still has to be done on your server-based stuff. So you can use cloud to ease certain things for you, make some things possible for you, reduce the cost for doing certain things and so on. And that's about it. Otherwise, see, you have your server within your company's LAN. To access that, you may need a VPN connection and so on, which may be a problem. But if you have it on the cloud, you can actually manage the IP addresses, security, and so on, and then you can test it from anywhere. So if you have those kind of situations also, cloud is a good idea. Another thing that you have that's a good idea is if you have distributed testing in different countries. So if your server goes down, which is your bare metal server sitting in one location, it's only the next day that the person would come and restart it and so on. So in those cases also cloud is a good idea. Yeah. And then a lot of tools that you have, if they are on the cloud, it's a good idea because everybody can access it. For example, Jira and test management and so on.
For now, we have to finish.
Yeah?
One card for T-shirt is for you, and another one we should give for someone here.
Okay,
For
so
questions.
let me remember the questions. I like that question very much because this is a very practical problem. So
Okay.
it's not recency effect. It's not because he was the last one to ask the question.
Like all time, really.
Thank you so much.
Thank you.
Namaskar.